One of the most interesting questions that people are asking right now in the world of macroeconomics is whether or not all of this technological growth, and especially the growth in artificial intelligence and robots that use artificial intelligence, are going to destroy all of the jobs. And so this is one of the questions that economists have been asking for centuries. And what we're going to do in this chapter, which is chapter 15, is to look at the relationship between uh, long run growth and the unemployment rate, right? And so we know that the unemployment rate goes up and down over the business cycle. We saw that in the last few chapters where we looked at the business cycle and fiscal policy and monetary policy. What we're looking at now really is things on a much larger scale. So from 5 to 10 years, but then even going back hundreds of years in different countries. And what we want to see is whether or not faster technological growth leads to higher unemployment or vice versa, and why some countries experience higher rates of unemployment than other countries, and what are the institutions and policies that might affect the unemployment rate. So if we look at the unemployment rate, sort of going back almost 60 years now, we can see that countries have had pretty big different experiences with the unemployment rate. So, Spain has had pretty high unemployment for in a different couple periods. So they had unemployment rates around 20% in the 1980s, and then again after the Great Recession. Whereas other countries like Japan have had very low unemployment rates of 2 to 3%. Obviously, that's a big difference between having 2 to 3% of the people who want jobs not working to 20% of the people who want jobs not working. You can see that there's been a lot of ups and downs, some of it related to the oil shocks. And what we're going to look at really is sort of these different countries and how they've experienced unemployment and whether or not that seems to be related to long run technological growth. So what this graph does is to put the average unemployment rate from 1970 to 2011 on the horizontal axis and real wage growth at the same time period on the vertical axis. And what you can see is that there isn't really any great relationship. There doesn't seem to be any causal relationship between the unemployment rate and real wage growth. Norway and Japan have been up here with really low unemployment rates but high wage growth. The U.S. has had pretty low unemployment rates, or at least not worse than average, but really not great wage growth since 1970. The fastest wage growth in the United States took place in the 1950s and 1960s. We can see Spain over here as an outlier, has had really high unemployment rate, and then a lot of countries sort of in the middle here with unemployment between 5 and 9% on average, and wage growth between 1.5 and 2.5%. Obviously, what a country would like to do, if possible, is to keep the unemployment rate low and real wage growth high. And so we're going to see, are there some policies that might help contribute to that in countries that a country like the United States or any other country could adopt. So the first thing we're going to look at in this video is technological progress and what we mean by technological progress and how we measure technological progress. And so when we think about what technological progress is, what we want to think about is how much capital workers have to work with and how much they produce. And so it's not surprising that a country like the United States that has a lot more capital per worker produces a lot more than, say, China does, which has less capital per worker. But what we want to think about is not just adding capital that workers can work with, but adding better capital, adding more technologically advanced capital so that workers can produce more. And then what we're going to do is look at the role of creative destruction. And so the short answer is that does technological growth cause job destruction? Yes, it does. But it also allows for job creation. And so that's the second piece that we're going to look at and see whether or not more jobs get created or more jobs get destroyed. So the way we look at a production function is we have capital per worker on the horizontal axis and output per worker on the vertical axis. And we usually measure technology using the letter A, and is often called the Solow residual, named after Robert Solow, who was the first one who thought about modeling the production function in this way. And so what you can see is that we generally consider that we have a production function that has diminishing returns. So each additional unit of capital adds output, but at a slower and slower pace. So if we look at point A, we can see that the level of increased output we get per worker by 1 unit of capital per worker is just the slope of the production function, right? So A is equal to the change in Y divided by the change in K. The rise over the run, if we're just doing linear, or the derivative of the production function in terms of calculus. And you can see that the slope down here is much steeper than the slope over here at point A, right? So we get more bang for our buck when we're over to the left of our production function than when we're over to the right. However, technological progress means that we can shift our production function up, right? And so if we shift our production function up, then for any given level of capital per worker, we're able to produce more. And that's what we mean by technological progress, is this shift up in the production function. So for example, point C would not have been available at our earlier production function, but once we have a better technology, we're able to produce that much more than before. We remember that we can measure the average product of capital by using the slope of the ray that goes through the origin to a point. And so the average product of capital is going to be the same at point B and C because the ray goes through both of those points. So we can see if we put capital per worker on the horizontal axis and GDP per worker on the vertical axis, this is for countries in 1990. You can see that while this isn't a perfect description of how much countries can produce, it's a pretty good description. And so a country with a lot of capital per worker like Switzerland is producing more than a country with a medium amount of capital per worker like Belgium, which is producing a lot more than a country with a low amount of capital per worker like India. At this point in 1990, India is really sort of just starting to hit its growth stride. But there are big differences, right? So Japan and the US have very similar levels of capital per worker in 1990, but the US is producing a fair amount more. And so there are some variations, and we're going to look at some of those variations when we think about the role of technology and its relationship to unemployment. So if we think about history, we can see that a lot of countries have experienced pretty similar rates of growth. And so if we just fill in some of these spots here, we have the UK GDP per worker here on this insert graph. And you can see that we have, a number of countries and their growth paths. So the U.S. has actually experienced somewhat better growth than other countries, at least since 1800. The UK is similar, but is at a little bit lower place. Taiwan and Japan were traveling pretty similar paths in terms of output per worker and capital per worker. And as we said, India has sort of just started by 1990, and so they're at a higher level of GDP per worker now than they were then. So again, you can see that while these countries are similar, they were certainly not identical in terms of their growth history.